Okay, so now we're going to discuss alligation. So alligation is going to involve adding two or more different strengths of medications together to get a final result. So the first alligation method we're going to go through is called alligation alternate. So if you're following along in the book, we are on page 373. Page 373 does a great job about outlining the steps that we're going to follow. And then 374 walks you through an example. So if you're still struggling after these examples that I go through, refer to the book. Usually this is a little tricky the first time we go through it, but students really tend to think this process is easy once we get the hang of it. So alligation alternate is commonly referred to as the tic-tac-toe method, and you'll see why in just a second. So we're going to be calculating how much of two different ingredients that we would need to combine together to make a final strength. So with alligation alternate, we're combining two different solutions here. One of each with different strengths, and we're going to combine those together to find a strength somewhere in between the two. So we need to still be following our rules. So making sure that all of our units are in metric units, all of our ratio strengths, or any other type of strength is converted into a percentage strength in this case, and that all of our units are the same. So just remember your final strength must lie somewhere between the strengths of the components. And I'll talk about that here in just a second as well. So I know this probably looks overwhelming at first, but I promise it's not that bad. So it's called the tic-tac-toe method because we're always going to start out by drawing a tic-tac-toe board. We're going to start by putting the higher strength solution in the top left, the lower strength solution in the bottom left, and then our desired strength right in the middle. And then from there, we're going to determine how much of each solution is needed to make our final desired quantity. So the easiest way to do this is to just jump right in to an example. So let's take a look at number 6 on the worksheet. So here it says, prepare 2 liters of a 55% weight to volume solution from a 35% and a 75% solution. So first of all, this is what we want to make. So this is our desired. These are the two different stock solutions that we're using. So anytime you have two solutions here, we got to make sure that our desired concentration falls somewhere in between these two numbers. So 35 and 75, between there, well, 55 would fall right in the middle there. So this one will work out fine. The point I'm trying to make is that you cannot combine, for example, you couldn't combine a 55% solution and a 75% solution and ever get a 35% solution because that would have a way lower concentration than either of these two ingredients. So just think about it logically, you know, this is a higher concentration, meaning it has more active ingredient. This is the lower concentration. So we're going to find out how much of each of these solutions we need to add together to get a final strength of a 55% solution and a final quantity of 2 liters. So alligation alternate, always start out with a tic-tac-toe board. So just like so. Now, step 1, put your higher concentration in the top left. So our highest concentration is 75%. Step 2, put your lower concentration in the bottom left. The lowest one that we have is 35%. Step 3, put your desired concentration right in the middle. So we're trying to make a 55% solution. Now, step 4, we're going to subtract diagonally. So we're going to go this way. 75 minus 55, that leaves us with 20. And you don't have to put a percentage here. We're just going to leave that as whole number 20. So we took 75 minus 55 is 20. Now we're going to go this way. And this way, you are never going to get in a negative number, okay? So we're taking 55, we're taking our desired minus 35. So 55 minus 35 also gives us 20 here. So now what we've done is figure out how many parts of each solution that we need. So we need 20 parts of a 75% solution and 20 parts of a 35% solution. Now, that doesn't really tell us much. That doesn't tell us how we can measure these out. So the next step is to find how many total parts we have. So 20 plus 20, well, that gives us a total of 40 parts. So we're going to take each of these and set them over our total amount of parts. So I have 20 parts over 40 total parts here. And then we're going to take this fraction and multiply that by our desired quantity here. Now, this is in liters. I'm going to convert this into milliliters first, because that's going to give me with milliliters in my answers over here. So 2 liters is equal to 2,000 milliliters. I'm going to take this equation here times 2,000 milliliters. And this answer is going to give me how many milliliters of a 75% solution I need to use. So in your calculator, if you take 20 divided by 40, you are left with 0.5. So 20 divided by 40 gives you 0.5, and then you're just going to take that times your 2,000. So times 2,000, that leaves me with 1,000. So now I need 1,000 mils of my 75% solution. And I'm going to do the same thing here. So 20 out of 40 times my total. And we see here, this is the exact same problem. So this one's going to work out the exact same way. So now I also need 1,000 mils of my 35% solution. So the way that you can check your work to see if these quantities are correct is if they add to equal our quantity. So 1,000 plus 1,000 does equal 2,000. So we know that we've done this correct. So now my directions here, I want you to visualize what we're doing. So we're going to add 1,000 mils of a 75% solution to 1,000 milliliters of a 35% solution to make 2,000 mils of a 55% solution. So that would be my directions. Add 1,000 mils of a higher 75 concentration to 1,000 mils of a lower 35% concentration to make a total of 2,000 mils of a concentration that is in the middle here of a 55% solution. Okay, so let's go through one more example together here. So in stock, we have two ointment strengths. We have a 12% and a 24% boric acid strength. How many grams of each are needed to make 2 grams of a 20% ointment? So in this case, we have two different strengths. We're trying to combine a third strength that is somewhere in the middle, which 20% does fall between 12 and 24. So this one will work out just fine. So this is an alligation alternate problem. So once again, always start with your tic-tac-toe box. Higher strength goes in the top left. So the highest one we have is 24%. Lower strength goes in the bottom left. Lowest is 12%. And our desired goes in the middle, so 20%. Now we're going to subtract diagonally. So 24 minus 20 leaves us with 4 parts here. And then 20 minus 12 this way leaves us with 8 parts here. Now we need to figure out how many total parts we have. Well, 8 plus 4 is 12. So we're going to put each of these over 12 total parts. And then the next step is to multiply each of these by our total quantity. So we want to prepare 2 grams. Now my question is asking for how many grams. So I'm going to leave this in grams. So take this times 2 grams times 2 grams. So now from here, you should be able to solve. So do your division part first, leave that in your calculator, then take that times 2. That's going to give you your amount of 24%. Same thing here, solve this one. That's going to give you your amount of 12%. Then what I would like you to do is write out the directions for this compound. After you have completed number 7, then you can move on to number 8. So in this case, it says prepare 120 mils of a 5% solution using a 1 to 10 solution and a 1 to 125 solution. So the first thing you're going to need to do here is convert these ratio strengths into percentage strengths before you can plug them into your tic-tac-toe equation. So if you're still struggling with this concept, like I said, go back to last week's recordings. Make sure you understand how to go from a ratio into a percentage strength. Then I would like you to solve the alligation alternate for each of these solutions, and then write out the directions to make this compound.